All right, my friends, is this getting fun yet? As soon as you get the hang of it, it's kind of fun. It's like advanced math brain damage. You start thinking this is like super fun. Anyway, let me know when the brain damage occurs. All right. So for this problem, let's think about what's your a value. I'm going to make a note this time since it's a smidge trickier. So what's your a value? It's the constant that's getting squared, so it'd be 1. And what's your u value? It would be the function of x when you square the quantity, you get 4x squared. So I hope it makes sense. Your u value in this problem is 2x. So your substitution for this problem would be that 2x, or u, is equal to a, which is 1, which you don't have to write, but tangent theta like that. Hopefully that makes sense, my friends. And then if that's the case, then x would equal 1/2 tangent theta, and dx would equal derivative of tangent is secant squared. There we go. Okay, so writing this integral in terms of theta, we'd have 1 over the square root of 4x squared. Let's see if you just square both sides of this expression. You'd get tangent squared theta to go in that spot, plus 1. And then dx, don't forget to swap that out, is 1/2 times secant squared theta, d theta, like so. Okay. All right. Now let's simplify this. So we've got 1 over, let's see, what is tangent squared theta plus 1 Pythagorean for? And that is Pythagorean for secant squared. And then you square root it and you just get secant for that entire square root down there in the denominator. There you go. I just brought the rest down and now it's cancel time. And what are we left with? The 1/2 could be factored up front if you want, and you're left with just the integral of secant theta d theta. Oh man. Let's see, what is the antiderivative of secant theta? It is the natural log of the absolute value of secant theta plus tangent theta plus c. There you go. All right, and why aren't we done? Because we're supposed to give our answer in terms of x. Okay, so let's get the easy part done. Tangent theta is totally just equal to 2x, so that's done. And then let's see, I'm going to do this. Yeah, I think since I'm just going to steal from that. So since tangent of theta is equal to 2x, which is the same as 2x over 1, I could draw a little right triangle. And 2x would be opposite and 1 would be adjacent, and a little Pythagorean theorem work, and I've got the length of the hypotenuse. And then what would secant of theta be? Well, secant is 1 over cosine. So if cosine is adjacent over hypotenuse, secant would be hypotenuse over adjacent. So here's hypotenuse, here's adjacent. So that means for secant theta, back over here, I can replace that with the square root of 4x squared plus 1. So my final answer would be 1/2 times the natural log of the absolute value of square root 4x squared plus 1 plus 2x, close absolute value, plus c. All right, my friends, big, big, big high five if you got all the way to the end. But seriously, congratulate yourself if any of that makes sense. All right. Feel free to scare your friends. I know you've got friends in Accelerator Pre-Cal, right? Like, I'm sure you've been scaring them with your homework, right? All right. Go ahead and give example 3 a shot. Example 3 follows tip number 3 for integrals involving the square root of u squared minus a squared, again, where u is the function of x and a is a constant. For these, it would work out. If you want to get basically like kind of that perfect Pythagorean swap situation, you should let the u, which is, remember, that's a function of x, equal your a value times, any guesses? Oh yeah, secant theta. There you go. All right, this is our last example for this lesson. So if you haven't gotten one all to the end, this is the one for you. See how it goes. Check in with me in the next video.